The next thing we're going to do in this section is take a look at a couple of common applications, specifically business applications that involve derivatives. We've already learned that the derivative is the same thing as slope of the tangent line. So as to write tangent lines, you are finding derivatives. It's the same thing as instantaneous rate of change. And the new application I'm going to give you today is the derivative of a cost function or a profit function or a revenue function is often referred to as marginal. That word marginal means find the derivative. So marginal cost is the rate of change of the cost function. So let's take a look at a specific example. In this problem, we are given a cost function. It says the cost function to produce Q 1,000 items is given by the following. The demand function for the same product is given by another function. So Q is still number of items, and P stands for price per item. Part A, find the marginal cost when 10,000 items is produced. So first, marginal cost means derivative. So I'm going to find the derivative of that cost function. Let's see, derivative of 3,000, that is a constant. Derivative is 0. And then I've got 0.2 q squared. So my derivative is going to be 0.2 times 2q, or 0.4 q. Now, if 10,000 items are being produced, that means my q is 10. Because Q is where does it say? Now, if 10,000 items are produced, my Q is 10, because Q is given to us in thousands of items. So I'm going to take 10, and I'm going to plug that into my derivative function. 0.4 times 10 is 4. My units would be dollars, because cost is measured in dollars, per 1,000 items, because Q is measured in 1,000 items. Now, what is this telling me? This is a rate of change of cost. So this is telling me that if I increase the number of items produced, the cost is going to increase. So the cost will increase by $4 per additional 1,000 items produced. All right, part B asks us to find the marginal revenue when 10,000 items are produced. So again, that word marginal means derivative. We want to find the derivative of the revenue. Now in this problem, they didn't actually give us a revenue function. Instead, we're going to use the fact that the revenue you make, the money you bring in, is always going to be the price that you pay, price per item, times your number of items. Revenue is always going to be P times Q. This fact might come up in future sections. This is a good thing to have in your notes. Revenue is always going to be price times number of items. And so in this problem, the demand function gave us the price per item. I copied it down over to the side. And so if I want to write a revenue function, I'm going to take that demand function and multiply that by Q. Now I'm actually going to do the multiplication and the division so that I can find the derivative using my sum and difference rules. So I start by distributing the Q to the numerator. The Q doesn't get distributed to the denominator. It's like we're multiplying by Q over 1. And then I'm going to do the division. 30,000 divided by 10,000 is 3. And the negative 1 divided by 10,000 should be negative 0.0001 q squared. Now I can find the derivative of this thing. The derivative of 3 is 0. And the derivative of our negative 0.0001 q squared would be negative 0.0002 q. And then finally, if I want to find out what is this derivative when 10,000 items are produced, I'm going to plug 10 into that derivative. And I end up getting negative 0.002. Again, revenue is in dollars, so this is dollars per item, or in this case, dollars per 1,000 items. Because my marginal revenue is negative, this is telling me if I increase the number of items produced, the revenue is actually going to go down, very, very slightly, but the revenue is going to go down. Finally, we are asked to find the marginal profit. To find the marginal profit, we are going to use the fact that your profit is always your revenue minus your cost. So that means marginal profit has to be marginal revenue minus marginal cost. And we've actually already found our marginal revenue and our marginal cost. And so to find the marginal profit, I can actually just subtract those numbers. I'm going to take my marginal revenue, which is negative 0.002, and then I'll subtract my marginal cost, which was 4, and that gives me negative 4.002, again, dollars per 1,000 items. So the marginal profit is also negative. That tells me if I increase the number of items I produce, my profits are actually going to go down. And that makes sense because we learned that our costs will go up, but our revenue will go down. All right, let's do one more example of an application of derivatives. For the function f of x equals 2x to the third minus 15x squared minus 36x plus 15, find x, find all values of x, where the tangent line is horizontal. So first of all, if you have a horizontal tangent line, well, if you have a horizontal line in general, that means the slope is 0. Horizontal lines have 0 slope. And the slope of the tangent line is defined to be the derivative. So this problem is basically asking us, where's the derivative equal to 0? Where is the slope of the tangent line, the derivative, 0? So I'm going to start by finding the derivative. The derivative of 2x to the third would be 6x squared. Then we get a minus 30x minus 36, and the derivative of that constant 15 is 0. Note the derivative of the negative 36x is negative 36 times 1 x to the 0. 1 minus 1 is 0. X to the 0 is just 1. That's where that negative 36 came from. You can also think of that as a linear term. Negative 36x is a linear term. And so the derivative of a linear term is just the number in front of it, just the slope. Okay, so where is this derivative equal to 0? I'm going to solve this by factoring. I notice that all of these numbers are divisible by 6. So I pull the 6 out first. Product of negative 6, sum of negative 5. I think negative 6 and positive 1 work. So I get x equals 6 and x equal negative 1. Those are two x values where this function has horizontal tangent lines. That's it for this lesson. As always, let me know if you have any questions.